All right, so first thing you're going to take a look at before we even really start the first lesson is just look at the word trigonometry, kind of break it down, see if we can figure out what it actually means. All right, so if we separate that word into like a prefix and a suffix, and we can kind of figure out what those two things mean, then we put it together, we can figure out what trigonometry is all about. Does anybody recognize anything there at all as like a prefix or a suffix that might mean something? Yes, Ellie?
Try.
Try. Okay, what does that mean?
Like a triangle, 3 sides.
3. Right? So try by itself means 3. Now, if you extend it to trigon, whenever you put the word gon at the end of something, it means sided. Right? Like hexagon, pentagon, octagon. Right? Well, trigon is another name for a 3-sided shape. We normally call a 3-sided shape what? A triangle. Okay, we normally call it a triangle, but there is a name ending in gon, and it's called a trigon. Just like a 4-sided shape, we normally call it a quadrilateral. Well, the name ending in gon, that means a 4-sided shape. Does anyone know that one? There's a prefix that means 4 beside quad. It's a different one. It ends with a T. What is it? No? Tetra. Yeah, it's tetragon. So a 4-sided shape is also called a tetragon. And if this class was all about studying 4-sided shapes, this would be tetragonometry. But it's not tetragonometry, it's trigonometry, because it's 3-sided shapes. Right? And then metry. Metry is a suffix you see at the end of different, a bunch of different subjects. So you've got trigonometry, geometry. I guess that's it. But metry means study of, or even better, measurement. Say it that way. So measurement. Metry means measurement. So what we're really doing in this class is we're studying how to measure things that have 3 sides, right? 3-sided measurement. So an example of a problem like that would be something like, let's say you had a building, and you're standing right here, and you know that you're 50 feet away from the building. So that distance is 50 feet. And what you want to know is the height of that building. Well, you can find the height of it if you make a triangle, but you got to know a little bit more information than just that. You'd have to know one other thing, like maybe the angle to the top of the roof. So if you had what's called a transit, it's a device surveyors use. You might see people like on the side of the road with a tripod set up, and they're looking through it, and then down the road there's like another one. Well, usually they're shooting a laser to measure a distance or maybe an angle or property lines. Well, you can use one of those to measure the angle to that roof. And then what you've just created is basically a triangle, right? Like this. And now using that triangle, and let's say you measured that angle and it came out to 40 degrees, you could find the height of that building. So that's a pretty straightforward one. Okay. Another example, a little bit more complicated, is let's say you've got a forest. Okay, all that green represents forest. And in the middle of that forest, there's a tower, actually 2 towers, right? And they're like fire watch towers, so they're, usually there's a park ranger in them. But let's say there's a tower. Let's do this in black. There's a tower here, and there's another tower on the edge of the forest over there. And let's say there's a fire right there. And they want to figure out exactly where the fire is. Well, if it's in the middle of a bunch of trees, you can't really say it's over by the tree. Yeah, which one? So they need a little bit more accurate way of describing it. And as long as each tower can see the fire, they can triangulate exactly where the fire is. You might have heard that word before, like triangulating someone's position. That's exactly what you can do here. The distance between the two towers would probably be known because the two towers are built, their locations, you can look them up on a map, just like Boston and Chicago. You can look them up, you could measure how far apart they are and figure out the distance. So that distance would be known. Each tower, if they can see the fire, can basically say the direction they see the fire at. Like this tower can say, you know what, I see the fire, but all I can tell you is it's that way. I don't know how far that way. Maybe it's 10 miles, I can see the smoke. Maybe it's 15 miles, maybe it's 30 miles. But I can tell you the smoke is coming from that direction. Well, this other tower can do the same thing. Each tower by themselves can tell you the direction the smoke is coming from, but they can't tell you how far away the smoke is. But working together, if they each can say the direction, I see it this way, you see it that way, they can pinpoint exactly where the fire is. And that's how, that's another example of trick. A little harder because this time there might not be a right angle in this problem. Okay, when you deal with triangles that have right angles, like that, a little easier. So that one would be a little harder. In that kind of example, you could extend to like a boat in the ocean. Maybe two different boats can see another boat that's in distress, and those two boats can work together to figure out where that other boat is. So it's all different kinds of examples of triangulation. Cell phones, you can do it with cell phones too. Figure out exactly where somebody is just by them having their cell phone. It has to be on, but you can do that too. All right, so a couple different examples of trig. Both of these are pretty far away from anything we're going to cover in the next week or two. So 3 or 4 weeks away. All right, so the very first thing we're going to look at, I guess kind of has to do with that problem a little bit, but it's much simpler, is just finding the distance between 2 points. Okay, so when we deal with coordinates, there's 2 formulas we're going to look at. One is finding the distance between 2 points, and the other one is finding the halfway point between 2 points. This is the only section that we're going to do in Chapter 1. Okay, there's a lot of other sections, but we skip around, so we're going to start Chapter 2 tomorrow. All right, so we're going to do the distance formula. We're going to do it in 2D. So it's basically going to be for something that's flat, like a piece of paper, and you got a map, and you want to know how far apart 2 points are. We're not doing it for 3D. Okay, not yet. So if you want to know how far apart 2 points are, well, first thing you need is coordinates for those points. If this was an actual problem, those would all be numbers. Okay, x1 and y1 would have a numerical value, so would x2 and y2. What I've done is I've just drawn, well, I need to scroll down a little more, but I basically, bless you, put these points on the board. Bless you. Point A and point B. Okay, you can see point B, but point A is a little bit lower, it's off the screen. Okay, there's point A. Now, A and B could be in any quadrant. Just to make this simple, I just put them both in kind of in the upper right, but they could be anywhere. All right. And my goal is to find out how far apart are A and B. So a lot of times the approach that we're going to take in trig to figure something out is going to be to draw a picture. And most of the time, 9 times out of 10, we're going to draw a certain shape. And if you listen to me explain what trigonometry is, then you probably know what shape we're going to draw. Does anyone have a guess what shape we can make out of what I've started to put on the board? Yeah? Yeah, we're going to make a triangle. What I've done is I actually made one right there. So that triangle in red represents kind of what I'm trying to find. So If that's a 90, what's the side that's across from the 90 called, the longest side? It's the hypotenuse. So basically, I've turned this problem into finding the hypotenuse of a triangle. Now, there's a theorem from geometry that you can use whenever you want to find one of the sides in a right triangle. We want to find the hypotenuse. But does anyone remember what that theorem is called? It involves the three sides in a right triangle? The Pythagorean Theorem, yes. The key is we just need to know two of the other sides. So let's kind of highlight the other two sides. So I've got this side, which I need to figure out the length of. And then I've got this side. If I can find the length of the blue and the green, then I can automatically get the hypotenuse. And you might say, well, can't we just count? We can't really count to find the length of the side that's the hypotenuse because it's on an angle. So if you want to find the length of something on an angle, there's no way to count the spaces. But if you've got something that's perfectly horizontal or vertical, yes, you can. You can count the spaces. 1, 2, 3, 4, 5, 6, 7, 8. I know that bottom side is 8. I can count up. 1, 2, 3, 4. Now I can find the hypotenuse using the Pythagorean theorem. Now, let's say I don't have it on a grid though. All I have is coordinates. So, let's just do it like this. There's my x-axis. Here's my y-axis. It's kind of like what we have. Again, you don't have to redraw your diagram. Just watch this part, and we're going to go back to my diagram in a second. This coordinate is 2, 3. This coordinate is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3. So if all you had was 2, 3 and 10, 3, and you didn't have a visual, how could you find the length of that bottom side if all you knew was the 2, 3 and the 10, 3?
So it'd be like 10 minus 2.
Yeah, you use subtraction. If you're trying to find how far apart this point from this point is, all you have to do, because it's horizontal, is look at the x values. One of them has an x value of 10. One of them is at 2. The difference between 10 and 2 is 8. So you have to find the difference. And what would you do here? This one is 10, 7. How could you find that the height is 4? What would be a calculation you could do? If you didn't have a visual, all you had was 10, 7 and 10, 3. Yes?
Subtract the 7 from the 3.
Right. If you're trying to find the height of something, focus on the y values. The y values go up and down. The difference between the y values is 4. So the whole key is you're finding the difference. So let's see if we can do the same thing here. I've labeled coordinates A and B. I'm going to label this coordinate in the lower right. How could I label it? The labels that I need for it are already on the board. If you kind of look at the pattern here, if you wanted to label that coordinate, all you really have to do is look at this coordinate, look at this coordinate, and pull a piece of information from each of them. Anyone have a guess how we would label this coordinate in green in the lower right? Yep, Ellen?
x2,
Let's see, x, I agree, it's x2 because it lines up with the point that's right above it. So point B is exactly the same distance over as this one, so x2. And then y1 because this point and this point are at the same height. So just grab the height from the first one, y1. Okay, so now we've labeled it. Now let's find the length of the side in blue. So Jake, if I want to find the distance between two things that are horizontal. Do I focus on x values or y values? Which letter is the horizontal?
X.
Yep,
Horizontal.
the x. And Aiden, what operation did we say we do to find the length of something? You take two numbers and do what with them? Like if I said something's at 12 and something's at 5, and I want to know how far apart 12 and 5 are. Subtract. So you're going to take the x value here minus the x value here. And let me put it right here. That's the length of the bottom side. x2 minus x1. Aaron, how would I find the height from here to here? What would be my calculation for that?
You subtract y2 from y1.
Yeah. Y, well, or y, it doesn't matter if you do y2 minus y1 or y1 minus y2. I'll just do it the same way we did the other one. And the reason the order doesn't matter is because the Pythagorean Theorem basically is going to make it so the order doesn't matter. Can someone remind me, what is the Pythagorean Theorem?
A squared plus b squared plus c squared.
All right, what does that mean? Because I don't have any ABs or Cs on the board right now. I mean, well, I have a B here, but I don't have like a C. So what are those from? Sides. What side is this one?
The bottom.
Okay, so the bottom and this one?
The vertical.
The vertical. And what do you call those two sides in a triangle?
Legs.
They're the legs. So these are the legs. And what about C? It's the hypotenuse. So if you want to find the distance between 2 points, which is that segment in red, all you really have to do is find C. Now this formula is giving me C squared. How could I make it so it's just C on the right side? I don't really want length squared, I just want length. Yeah, take the square root. So that is the distance formula. It's just the Pythagorean theorem rewritten a little bit. Just fill in for A, the length of the bottom side. Just say, Kyle? Kyle, right?
Yeah.
Yeah, just like Kyle said. Fill in x2 minus x1 for the length of the bottom. Fill in y2 minus y1 for the vertical. And there's your distance formula. So let me write it out. So I've got my square root, and instead of a and b, I did x2 minus x1, that's the bottom, y2 minus y1, that's the height. And there's no way to simplify that without putting numbers in it. You can't cancel this square root and this square because of the plus sign. That messes that up. All right, so until you put numbers in, that's as simple as you can make it. And that's your distance formula. Okay, so on the test, the first 4 problems, 2 of them are going to be using this formula. The next 2 on the test are going to be the formula I end with after this one. All right, so when they ask us to find the distance between 2 points, what I usually do first is just label the 4, the 5, the 3, and the 2 with the x2, x1, y2, and y1, just so we know which number is going to go where. So, Jose, let's start with the 4. What could I label the 4 as? I actually have 2 choices. X1 or
X2.
it could be x1 or x2. It doesn't really matter right now. I'll just call it x1. Now that I've called that x1, I don't have any more choices. Everything else is automatic. So Connor, what would the 5 be?
It'd be Y1.
Yep, be y1, and this is your x2 and your y2. Fill in those 4 numbers in the 4 spots in the formula. So the distance. I always put the square root first so I don't forget. x2 minus x1, 3 minus 4. Don't forget to square it. Plus y2 minus y1, 2 minus 5. Don't forget to square it. And plus sign goes between them. Now, I said to you the order doesn't really matter, like if you do x2 minus x1 or the other way around, and that's because of what I'm about to do. I'm about to square it. 3 minus 4, how about Devin? What does 3 minus 4 give you? Negative 1, and if you square negative 1 is 1. Well, if you did it the other way around, 4 minus 3, that's 1. And if you square it, it's still 1. So it doesn't really matter which way you do it. 2 minus 5, it's negative 3. Squared is 9. So the distance here is going to be the square root of 10. In that particular problem, if they don't want a decimal, there's nothing else you can do. You're done. If they want a decimal, then you just type it down in your calculator and you get about 3.16. On the test, it will be clear whether or not they want a decimal. It'll say in the directions. If it doesn't say in the directions and it's a multiple choice question, then obviously you just look at the multiple choices and see, do they have decimals or do they have square roots? Circle the right one. Okay, questions on that? All right, let's look at one more distance problem. Okay, sometimes what I do before I even put numbers in is I do all of this. Because that's going to be the same in every problem. So I just start by writing down all the stuff that I need for the formula. Now I'll put in the specific numbers. Okay, let's just plug them in this time. We don't have to label x1, x2, y1, y2. If you want to, you can, but I think we can handle that. Kayla, what would be the first number that I would plug in?
2.
All right. You did 2, and the second number? 4. All right. She did it in a certain order. Let's just stick with that order when we do the next one. How about Caitlin? What would be the next two numbers?
6 and 10.
6 and 10. All right. So when we do that out, Peter, what's 2 minus 4? Yep, and then when you square it, 4. Plus, Maddie, what's 6 minus 10?
Negative 4.
Negative 4, and when you square it?
16.
16. Okay, so we get square root of 20. Now, if you know a little bit about square roots, anybody have anything to say about that answer? Square root of 20. Yep.
Did you break it down?
Yeah, we have to break that down. There's several different ways to break it down. This is the way that I usually do it. So if you want to leave a little bit of room, because we're going to break it down in a second, and just put this right below it. Or if you already know how to break it down and you don't want to write this, that's fine. So what I usually do is I look at the number underneath the root. It's called your radicand. And you try to write it as a product of two numbers. So in other words, you factor them. But you don't just want to pick any two numbers. You want to pick numbers out of this list. 1, 4, 9, 16, 25, and so on. So if I wanted to break down the number 20, does anybody see a number in this list that goes into 20? 4. So the way I can simplify the square root of 20 is like this. I can write it as the square root of 4 times the square root of 5. But actually, you know what? I'll do it even simpler first. I usually skip this step, but you can write 20 as 4 times 5. Okay. And then, once you factor it, step 2 is to break the root into 2 separate roots. Whenever you have a product under a square root, you can break it apart. If it was a plus or a minus sign, no, you can't. But multiplication, you can. And the reason we picked a number that was in that list of perfect squares is because one of these will now simplify nicely. What's the square root of 4? 2. 2, square root, 5. And there's your answer. So anytime you get a root that you can simplify, you need to simplify it. If you have another method that you use to simplify it, that's fine, as long as you simplify it. And we already simplified the square root of 20, so I'm not going to do that again. Does everybody have what's on the left? All right, so let's try one more root. We're not going to go through the whole distance formula, but let's say you did the distance formula and you got that as an answer. Square root of 48. How can you break down the number 48? Multiply two numbers together to get 48. And we want one of them to be a perfect square. Yeah?
12 and 4.
12 and 4. Okay? So if I do 4 and 12, and I get the square root of 4 is 2. Now look at 12. Can I break down 12 again? What does 12 break down as? 3 and 4. 4 and 3. So I have another square root of 4. So I have the original, I have the 2 times another 2 times the square root of 3. Well, it's fine to do it that way, and that's the correct answer. But if you have to break it down twice, it's because you didn't pick the biggest perfect square to start with. There's a bigger number that goes into 48. That's a perfect square. Bigger than 4. Yeah?
16.
16. Yeah. If you had done this to begin with, you would have been able to do it in one step. 16 times 3 is 48. Not as many people think of it because it's not a times table, but that is true. And the square root of 16 is 4. I mean, it's not that much shorter, but it was like 2 steps shorter. So there's always a way to do every problem in one step, but sometimes when the numbers get really big, it's hard to do it in one step. So I just break it down one step at a time until I get it as small as it can be. Questions on that? Yep.
Can you also go with like the tree thing?
Yeah, if you do a tree thing and then you get the final answer and you get that, that's perfect. Yep. As long as you get 4 square roots of 3, you did it right. All right, so the last thing we're going to look at is the midpoint formula. So midpoint formula basically shows you a way to find what's exactly in the middle of 2 other points. Midpoint formula works the same way in that you need 2 coordinates to make this work. But this time you're not going to find out how far apart they are. You're going to find out what's in the middle. Now, if you had numbers, like let's say you got a test score of 70 and a test score of 80, and I wanted to find out what's in the middle. What do we normally call that? A number that's, I mean, from statistics you might be a little more specific, but I'm just thinking basic. The what?
The middle, the median?
I'm thinking of another number, like when teachers give you a grade, like on your report card, it's not usually the median of your tests.
The mean.
The mean, right? So there's different kind of averages. Mean, median, those are both averages, but I'm thinking specifically of the mean. So how do you find the mean of a bunch of numbers? What do you do? Yep.
You take all of them, add them together, and divide it by how many numbers you have.
So if you had 2 things, you would add them up and divide by what? 2. And that's exactly what you do to find the midpoint. All it is the mean of the x's, comma, and then the mean of the y's. Because the mean of two things is what's exactly halfway between them. And that's what we're trying to find. Where is the point that's exactly halfway between two others? So when I think of the midpoint formula, that's all I think of. I think of, okay, find the mean of the x's, so add them up and divide by 2. Find the mean of the y's, add them up and divide by 2. It's a little bit easier formula than the distance because you don't have square roots involved. You don't have to square things. Basic addition and division by the number 2. So worst case scenario here, you're going to get a number that ends in 0.5 when you do the arithmetic out. It's as bad as the numbers really get. As long as you started with nice numbers. Okay, so let's finish up by finding the midpoint between those two coordinates. Jake, what are my two x values here?
3 and 7.
3 and 7. All right, so the midpoint formula says to add them up and divide by 2. So I'll do that. And Aiden, what are my two y values?
4 and 13.
4 and 13. It says to add them up and divide by 2. Aiden, would it make a difference if I did 13 plus 4 instead of 4 plus 13?
No.
No, that doesn't really matter. So my midpoint, Jose, what's 3 plus 7? Divide by 2. So we get 5. And Kayla, 4 plus 13.
17.
And if you want to divide by 2, you can just do it that way. Or if they wanted that as a decimal, what's half of 17?
8.5.
8.5. So that's it. That's your answer. Now, that thing I just circled, what is that? It's the midpoint, which is a coordinate. So when you use the midpoint formula, your answer is a coordinate. When you use the distance formula, your answer is a number, like 3.16. So you're getting two different types of answers. One is a length, one is a location. This one is a location. Okay. Any questions on that? Right, so homework tonight, it's mostly in the book, page 7. 15 to 21, odd. 39 to 43, odd. And I want you to simplify these 4 square roots. They're not in your book. Square root 40, square root 28, square root 108, square root 1440. And the other thing, which is not really textbook related, is just bring back the syllabus. Signed. Okay, so make sure you bring back the syllabus.